Okay. Given the function y equals f of x, just to review, when I replace x with a negative x, I get a reflection in the y-axis. If I replace y with a negative y, I get a reflection in the x-axis. And when I interchange the x and the y's, I get a reflection in the line y equals x, or an inverse reflection. So in this lesson, we're going to deal with equations. What happens to the equation under these transformations? So if I look at class example number 1, it says, write the equation of the image y equals x squared after a reflection in the line y equals x. So when I reflect in the line y equals x, what are my replacements? Yes. And I'm always going to come back to what are the replacements, because if you can identify the replacements, then you can put them into the equation. So instead of y equals x squared, I would have x equals y squared. And if I told you you had to write it as a y equals equation, it would be y equals what?
Square root of x.
Okay, and what should go in front of the square root of x?
Plus or minus.
Plus or minus. Okay. When we take the square root of a number, we generally don't deal with the plus or minus, but because we've got a variable, that's where the plus and minus comes in. With B, I have a reflection in the y-axis. So if I reflect in the y-axis, what is my replacement? X with negative x. So what's my equation going to be? Yes. Okay, so if I look at C, I have a reflection in the x-axis. So if I have a reflection in the x-axis, what's my replacement?
Y with negative y.
So what's my equation going to be? Y equals negative root x. Okay, the difference in class example number 2 is you're given the two equations, and the question is, how does the graph of the second function compare to the graph of the first? So if I have y equals x squared, and then I have y equals negative, or sorry, not x squared, x cubed, and then I have y equals negative x cubed, what was my replacement? X with negative x. And what reflection would that be?
In the y-axis.
What if I told you that this equation could have been written like this? Negative y equals x cubed. What would be the replacement that way? Y with a negative y. And what kind of reflection would I have? What this actually means is if you graph this on your calculator, x cubed and negative x cubed, it looks like it could be a reflection in the x-axis or the y-axis. I'm not going to expect you to give me both, but if you gave me either one of them, they would both be correct. It is correct to say that it's a reflection in the y-axis, and it would be correct to say that it's a reflection in the x-axis. One or the other, not both. It's not reflecting in the x and then in the y, it's just reflecting in one or the other. What about b? Y equals 2 to the power of x, and x equals 2 to the power of y.
X is replaced with y and y is replaced with x.
So what kind of a reflection is that?
A reflection in the line y equals x.
Yep. So reflection in the line y equals x. And then the last one, I have y equals sine x and y equals sine of negative x. What's my replacement?
X with a negative X.
So if I replace x with a negative x, what is my reflection?
To the Y-axis.
Reflect in the y-axis. Okay. So in C, you're given two equations. The thick line is a reflection of the graph in the thin line. And the question is, what is the equation of this transformation, of this transformed function? So if I look at A, I want to identify what's the reflection line. Is this line reflected in the x-axis, the y-axis, or the line y equals x? It's going to be the line y equals x. Because if it was the x-axis, it would go down. If it was the y-axis, it would actually be the same line. So my reflection line is here. So that's replacing y with x, x with y. So my equation, which was y equals x squared, would now be x equals y squared, or y equals plus minus the square root of x. Is this reflected function, or reflected equation, a function? No. How do I know?
Does it pass the vertical line test?
It did pass the vertical line test, and I have two possible outputs. So not a function. Okay, so if I look at B, what's my reflection line? The x-axis. So if the x-axis is my reflection line, what's my replacement? So my equation, which was y equals the absolute value of x, would become negative y equals the absolute value of x, or y equals negative the absolute value of x. So if we look at class example number 4, we're asked to start off by sketching the graph of f of x equals 6 over x squared plus 3. So use your graphing calculator to help you sketch that, please. You kind of get this graph that looks like a hill. This graph does not cross the x-axis because the y value is never going to be negative. Because no matter what x is, the minute I square it, I get a positive number, which when I add to 3, it still gives me a positive number. The other thing that this graph never does is it never equals 0. Because again, no matter, I can't get that negative to cancel out this positive 3. So question B asks us to write an equation for each of the following. So what am I doing with y equals negative f of x? Changing the y coordinates. I can think of this as being a y equals. So my replacement in this equation is what? What am I replacing? Y with a negative y. So I would get negative y equals 6 over x squared plus 3. To make y positive, I multiply it by a negative 1, which means I multiply the entire side, the other side, by negative 1. So when I multiply the other side by negative 1, I would get negative 6 squared plus 3. And I bring the negative to the outside, or to the front. If I look at the graph, so the graph is, the best way to do these graphs is to actually sketch the original in each of these. And then look at your reflection. I'm replacing y with a negative y, so this is a reflection in which axis? X-axis. So this is a reflection in the x-axis. So if I look at this and I reflect it in the x-axis, I get my graph that looks like this. A little bit more symmetrical when you're on paper. Okay, if I look at number 2, y equals f of negative x. What's my replacement?
X with negative x.
So I get 6 over negative x squared plus 3. So when I take negative x and I square it, what do I get? X squared. So I get y equals 6 over x squared plus 3, which is the exact same question that I got. So if I draw this out, I'll try to draw this a little bit more symmetrical this time. What's my reflection line? The y-axis. So I reflect in the y-axis. But because this graph is symmetrical along the y-axis, when I go to reflect it, this side reflects over to here, and then vice versa. So I get the exact same graph. So if you had put both of these equations into your graphing calculator, you would only see one. Then if I look at 3, what's my replacement?
X with y and y with x.
X with y and y with x. So my equation would now be x equals 6 over y squared plus 3. How do I write that as a y equals equation? So I have this as a denominator. How do I bring it to the top? What could I do? I can cross multiply. If I cross multiply, I will get y squared plus 3 times x equals 6. Divide by x. I now get 6 over x. Subtract by 3. So y squared equals 6 over x minus 3. And then I would take the square root. Y equals plus or minus the square root of 6 over x minus 3. So then when I go to graph this equation, I want to put in my reflection line, because first of all, that reflection line helps me identify an invariant point, because it's going to be the intersection where it crosses through. And then this point, which was at 0 and 2, becomes 2 and 0. And then I get a graph that looks like this. If none of the y values in the blue graph can be negative, that means that none of the x values in the inverse graph can be negative. which of these functions, or sorry, not functions, which of these graphs are not a function? So is this one a function? This one? No. Okay, so now if we look at class example number 5, given f of x equals 3x plus 2, determine the following equations, and then you're given the graph and asked to sketch them. So we'll go through these a little bit faster. What type of reflection am I doing in this first one? Or what's my replacement?
X with y and y with x.
X with y and y with x. So now I get x equals 3y plus 2. To get y by itself, I subtract by 2 and divide by 3. If I wanted this in the form of mx plus b, so I wanted the top two terms separated, I would have 1/3 x minus 2/3. My graph, to draw my graph, again, I want to have that reflection line that I can see, and then I pick coordinates that I can see, like this 0 and 2 was going to become 2 and 0. And this point here, which is at negative 2/3, is going to become 0 and negative 2/3. Just a second. Negative 2/3 and 0 becomes 0 and negative 2/3. And then there's my invariant point right there. So this graph would look like that. If I look at the second one, number 2, actually we're going to omit that one. 2 and 3 we omit because they're beyond the scope. So your questions